Okay, so just as a reminder, in this unit and in the last lesson, we've shown how relations can be shown in different ways. Ordered pairs, table of values, arrow diagram, graphs, even equations. Okay? We're going to talk about one type of relation, and it can also be a function. And most of these actually are. And we've been dealing with these actually already this year. A linear relation. Okay? A linear relation, actually, maybe you guys can define it. What do you think a linear relation would be? Like if we say on a graph, what do you think the graph of a linear relation would look like? Linear. Yeah. Straight line. So a linear relation is a graph whose points will always form a line. Okay. So let's take an actual example of something that a linear relation could be. And it's also going to, this one actually is also going to be a function because the domain values connect. Okay. So let's say some pizza place, they've got a special on for individual pizzas. They charge $5 plus 75 cents for every topping. Okay. So this is an example of a relation where we have the independent variable as the number of toppings. Okay. And the dependent variable is the cost, because the cost depends on how many toppings you get. So we can show it using a table, and from the table, we can graph it. So let's take examples for number of toppings. Well, first of all, let's assume that it's a cheese pizza. You get the cheese, so you have 0 toppings. How much does the pizza cost? 0 toppings. $5. Let's say you get 1 topping. $5.75. 2. Toppings. $6.50. 3 toppings. And 4 toppings. $8. So remember, in a table, the first column is the independent variable and it contains the domain. So if I ask you the domain, you go 0, 1, 2, 3, 4. The second column is the dependent variable. It contains all the range numbers. So we can show this using a graph where the independent variable is the number of toppings. Dependent variable is the cost. So I can start plotting points here. So 0, 5, go there exactly. 1 topping is $5.75, so somewhere around there. 2 toppings is $6.50. 3 toppings is $7.25. And 4 toppings is $8. Now think about the actual problem that we're working on right now. Should we connect these points to form a line? Okay, I see a couple of nods and a couple of shakes. Why no? No? Just felt like shaking your head? Don't want to back it up? Why, yes. Okay, it does. You're right. So it forms a line, but think about it. Would you put a line or would you put a point here? Why not? It's half a topping, right? Which doesn't make sense. And don't go, well, we have pizza. Don't start getting semantic on me. Okay? You have to order a full topping. Okay? So it forms a line, but we don't connect. Okay? So no. Because you can't have part of a topping. Now, the next question is, like I could ask you what the domain is, I could ask you what the range is, okay? I could ask you what the independent variable is, I could ask you what the dependent variable is. Another question to ask is this relationship linear? Well, if you look at the graph and the definition we gave above, these points would form a line, wouldn't they? Okay? So it's linear. They don't have to be connected to form a line. We don't actually form the line, but we could if we wanted to. Okay? So for a graph, look to see if the graph is already a line. Or a set of points that form a line. Okay, so that's how you can tell if a graph, looking at a graph, whether it's a linear relation or not. Okay. But what if you were only given the table? Well, I mean, you could graph it and then see. But pretend we didn't have the graph. How could we tell from just a table if it's linear? Any ideas? We did talk about this last year a little bit. How much am I going up by in number of toppings every time? One. Okay. And every time I go up by one topping, how much am I going up by in cost? 75 cents, right? Okay. So if you're going up by the same amount in one column and going up by, it doesn't have to be the same amount as the previous column, but if you're going up by another same amount in the other column, it's linear. Okay? So that's how we can tell if just a table is a linear relation or not. Okay? The first column, and actually I'm not going to say goes up,
I'm going to say changes,
because it could go down. It is possible.
the first column changes by the same amount. So in this case, it's going up by 1 with the pizza toppings. And the second column changes by the same amount. In this case, it's 75 cents, or 0.75. So that's how you tell if a table
Is linear. Okay. So what I'm going to do is I'm actually going to, for the time being, skip the second page. We're going to go to the first example. We're going to do examples 1 and 2, and then I'm going to stop there, okay? Because then we'll go back to the second page and then the rest of it on Thursday. Because that's kind of a separate topic within the lesson. So look at these tables. All you're asked is whether they're linear or not.
How much am I going up right here? Then? So it's all plus 5. So that's okay. How about this one? 9, 9, 9, 9. So I'm going up by the same amount. So linear. This one, we can see it's the same numbers here. So 5, 5, 5, 5. But how about the second column? How much? 75. But then 225, stop right there.
It's not going up by the same amount on the second column.
So you don't even have to check the rest. You know that it's not linear.
As soon as it stops going up or down by the same amount, you stop and say not linear. Okay? So there's an example of a couple of tables, seeing whether they're linear or not. Is this a function? Just out of curiosity? Yes. Domain values don't repeat. How would you write the range of this function? How would you write it if I said, write the range? What would you write? You guys did well on this on the test. So write all the numbers in the second column? Yeah. 32, 41, 40, 50, 59, 68. What kind of symbols would you put around them? Brackets? The squiggly ones, otherwise known as braces. Yes. Because it's just 5 numbers, right? We're not going from one to another. So we don't use the brackets or parentheses in this case. Okay?
Same with this one.
We wouldn't use brackets or parentheses for domain and range.
Okay, this one.
We are asked to graph each of these equations.
Well, remember, actually there were 3 different ways we graph
Graph these types. But you remember one of the ways we graphed it? With intercepts, yes. You could find the X and Y intercepts. What else could you do? Slope intercepts.
Y equals mx plus b. Or if you were stuck, do a table.
But let's either one would be fine, but let's do the slope intercept.
So remember, this is the slope. This is the y-intercept.
What would I do first to graph this?
Graph the y-intercept. It's 2.
And now I need a second point to draw the line.
Yes, use this, the slope. So from the y-intercept, go down 3 to the right 1. And there's your second point. And that's its drawing. Linear or not?
Yeah.
Yeah, because it's a line. Looks linear. I'm going to skip this one for the time being, because that's different than what we've seen before. So we're going to go to 3, y equals 4.
Remember how to graph this. Zara?
You go to the fourth place on the, wait, on the X line?
On the X,
Or no, on the, okay,
on the Y, yes.
Go to the 4, and then,
draw horizontal.
yes. Well done.
Remember, if it's just a Y in the equation,
Horizontal line.
automatic. If it's just a Y. Linear or not?
Yes.
Yeah, obvious, again.
And then 4, which is x equals 1.
Oh, you got this one. Gotcha.
One on the X. And then like you,
Like, draw a vertical line. Linear or not?
Horizontal. Remember, it's not just an X, vertical line, always.
Just an X, vertical, just a Y, horizontal, both X and Y slanted.
Okay, this one. I saved this one because it's something that we haven't seen a graph of.
Y equals X squared. Usually the best bet, and we're going to do this in grade 11 and 12, when we see an equation that we're not sure of the graph of, always start with the table.
See what it looks like. So I'm going to do a couple of negatives. I'm going to do 0
and I'm going to do a couple of positives. Remember, you get to choose the values for X. Usually it's safe to choose a couple of negatives, 0, a couple of positives. Okay? All right. Now we got to calculate Y. If this is -2, what's -2 squared? +4. What's -1 squared? +1. What's 0 squared? 1 squared. 1. 2 squared. 4. Let's plot those. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And actually, I would put arrows on the ends of each of these because I could pick a whole bunch of points. Linear or no? No, because it's a curve. This is actually something that we're going to be looking at early on in grade 11. This shape is called the parabola. Okay, yeah, fun to say. Well, what am I putting? Not linear. Not linear. Got a little excited there saying the word parabola. Okay. So first part of this, basically, I want you to understand what linear is. So if you see a table, you should be able to state whether it's linear or not. If you see a graph, and whether the graph has lines or curves or shapes or just points, you should be able to tell whether it's linear.